And so we're going to look at some questions on our practice exam. And I'll just do a couple of each type. I will set up all the applications because I know that we all struggle with those applications. So I'll at least set up the applications, and I'm going to try to do one or two of each type as well. So let's look at our practice exam. And let's look at the first question. Okay, the first question is zero factor. And I did pick questions that were easy to factor. So they're not going to be super, super difficult. You won't even have to do grouping on these. So we want to remember how to do zero factor. So if I want to do zero factor, I take the first, and if there's no number there, I add a 1. First number times the last number. And that gives you then a negative 36. And that goes in the box here. Now let's remember about our signs. Well, what do we know about the signs? Well, how can we get a negative 36? The only way we can get that is one positive and one negative, because that's the only way that you can get a negative number. And then we go to the middle, and let's remember that fact. We go to the middle, and we see that's a positive. So our larger numbers positive, smaller numbers negative. And I need two numbers that multiply together to give you that negative 36. Subtract from each other to give you 9. Can anyone tell me what two numbers that would be? Multiply together to give you 36. Subtract from each other to give you 9. Anyone know what the numbers might be? If we struggle with this, where do we begin? We look at the fact that we have 36. 36 is an even number, so it has to have a 2 in it. So 36 divided by 2. 2 and 18. 18 minus 2, that's 16. We want 9. Not going to work. So then we move up and we try a 4. 4 and 9. Okay? Does 4 and 9 work? No, because that difference is what? 5. Now, when we did 2, we got 16, which was larger than the 9. When we did 4, we got 5, which is smaller than the 9. So we know it has to be in between 2 and 4 now. And what's in between 2 and 4? 3. So 36 divided by 3 is 12. So what are my two numbers? 12 and 3, right? Because 12 minus 3 gives you what? 9. Is everyone okay with kind of how I did that? You can do that. You can just go through and you could have tried 2, 4, 6, 8, 10, 12. You would eventually got it that way. You can also try and trap it. Because if you're too high on one side, too low on the other, you know it's trapped in between. Now, they're going to be simple like this one. We're not going to have to factor by grouping, right? Because of that 1. So in this case, I can jump directly to my factors, which are here. And where students make a mistake is they get all the way to the end here, and then they say my answers are 12 and negative 3. Well, my answers are not 12 and negative 3, are they? What do we have to do? We have to set that x plus 12 equals 0 and move that 12 over. So you have to remember that your answer is a negative 12. You switch that sign, and x minus 3 equals 0. Moving it over gives you x equals a positive 3. Is everyone okay with that one? Let's do one more of these. Let's look at 3 just to make sure we're really comfortable with zero factor, because it's very, very important for the next chapters that we can factor. X squared plus 5x minus 14 equals 0. So put my 1 in front. Multiply. Negative 14 goes in the box. So let's answer this question first. What are my signs? Are they different or are they the same? Different. Why are they different? Because it's negative. Now, which one's going to be larger, the positive or the negative? Positive. Why? Because the middle is positive. Can anyone tell me what two numbers would work here? 7 and 2. Okay, 7 and 2. Positive 7, negative 2. We do not have to do factor by grouping, right? Because there's that 1 in front, so it actually is a very simple problem. And the ones on your exam are going to be like this. So we go ahead and factor this down. And we've got x plus 7 and x minus 2. So x plus 7 equals 0. So x now equals a negative 7. And x minus 2 equals 0. So x equals 2. And I'm going to leave question 2 for you to check, because you should know how to do that one now. You can check it in the back, because you do have the answer key. Right at the very back page, you do have the answer key, so you can check them all. So that was question 3. Now the applications, I'm going to set them all up. We struggle more with the applications than any other. We're really going to focus on how to set these up. These are the type that you're going to see on your exam on Monday and also on your practice, your take-home exam today that I'm going to give you. So question 4. Okay, this is a mixture problem. How much pure acid should be mixed with 8 gallons of a 50% solution to get an 80% solution? So when we talk about pure, remember that's going to be, in this case, pure acid, so 100%. If it was pure water, it would be 0. And so this is what we start with, right? Box number 1. We're going to add something to it, and we're going to get out box number 3, and this is what we want at the end. Each of these has an amount and a percentage rate. So we read it through. We identified the fact that this is a mixture problem. So let's now dissect it back into individual pieces. So how much pure acid? Well, we do not know how much pure acid, so we're going to use an X. That's what we start with. And that acid is 100%. So that's what we start with. We're going to now mix that with 8 gallons. So that's what's going to be mixed with it. 8 gallons of a 50% solution. So that's your box number 2. These add across because 1 plus 2 is 3. So that's x plus 8. And what concentration do we want to end up with? Well, we want to end up with an 80% concentration. And you've probably done a lot of these before, but is everyone okay with how I set that one up? It's a pretty simple mixture one. Now we get our pure. So let's go ahead and get the pure. And your pure is always your amount times the rate. And make sure your rate is a decimal. So on the first one, 100%, that's 1. 1 times x makes it simply an x. The second one, 8 is the amount. 50%, so that's 0.5 as a decimal. And then box number 3 is on the right-hand side. and that's 80%, so that's 0.8, and x plus 8 is in there. I'm going to leave this for you to finish. Okay, you can finish. You've got the equation. The hard part is always the setup. And that's where we need to spend our time. You should have no trouble solving the equation. That's the easy part. Where students always get stuck at is reading it, identifying what type of problem it is, and how to actually set it up. Question 5. Walt made an extra $8,000 last year from his part-time job. He invested part of the money at 2% and the rest of the money at 3.25%. He made $197.50 in interest. How much was invested at the 3.25%? So first off, we read it, and we know that this is an investment problem. And it's going to be set up in a very, very similar manner to the mixture one. And we've got amounts. And we have percentage rates. Walt made an extra $8,000. Now, what is that $8,000? Just to make sure we understand, that $8,000 is my total amount, right? So that's the total amount of money I have. So that goes over here. This is 1, this is 2, and my total amount of money is going to be $8,000. Is everyone okay with that? Right? Because that's your total amount, so it has to go here. That's where it belongs. What else do we know? You invest part of the money at 2, and the rest at 3.25%. Everyone okay with that so far? Now, once you've gotten to this point, we need to figure out the amounts. So let's start with the 2%. Do I know how much money I've got at 2% interest? No. So that means I have to use an X to represent that, don't I? What about the 3.25%? Do I know how much is in there? No, I still don't, do I? But I can't just use the X again. So I need something different. So what's going to go over here is going to be the total amount minus X. So what's going to go in here then is 8,000 minus X, right? Now you can see how it works because the sides should match up. And if I add these together, the positive X and the negative X, well, they cancel out, and you end up with 8,000 equals 8,000. So we know that the amounts check out. Let's go ahead and build our equation. And the equation in this case is going to be built off of the interest. And so your interest, and this is simple interest, by the way, your simple interest is the amount times the percentage rate. And make sure you add the correct number of zeros when you work with these decimals. So the first one, unknown amount, 2%, and 2% as a decimal is 0.02. And then we've got the X to go along with it, right? Because that's those two put together. We're going to add to that the second one, which is 0.0325, and how much is in there? 8,000 minus X. And here's where students sometimes make a mistake. This is going to be the total interest, not the amount of money. The total interest. And how much money did I make in interest? Well, I made $197.50. And I think you can finish it from there, right? But you see how I set it up? Question 6. We're looking at a rug here. A rectangular Persian carpet has a perimeter of 184 inches. The length of the carpet is 18 inches more than the width. What are the dimensions of the carpet? So first off, what are we trying to do? Well, we are working with a rectangle. And when we work with this rectangle, well, we want to find the perimeter. So the first thing I would do is I would draw a rectangle. So there's going to be my carpet. And what do we know about the perimeter? Well, the perimeter in any geometric figure is simply the sum of all sides. So when you sum up all the sides, you should get what's known as your perimeter. And we do have a number for that too. It says your perimeter is 184. So that's going to go here. So when I add up all the sides, I'm going to end up with 184. So first thing I did was I read it. Then I went through and identified the fact this is a perimeter. Perimeter is sum of all the sides. I drew my rectangle. And then when I proceed on, it says the length of the carpet is 18 inches more than the width. Well, I don't know the width. So I'm going to represent the width with an X. And the length is 18 inches more. So that's going to be X plus 18. Is everyone okay with that so far? Right? No problem there. This is actually a lot easier, I think, than the investment and the mixture questions. Now we want our perimeter. And what would the perimeter look like in terms of the variable? Well, the perimeter, again, is the sum of all the sides. So that's going to be X plus 18. And we've got two of those, right? Because there's top and a bottom. Then we've got a left and a right, so that's 2x. And what does that perimeter equal? 184. And now you have it. And now I think you can finish it from there. But do you see how I went through and I set it up? And you could have just added them all up. I just did the 2 because there's 2 of these and there's 2 of those. But you could have just simply wrote them all out, all 4 of them out, added them up. You're going to end up with the same result. But the key takeaway here is perimeter of any type of geometric figure is the sum of all the sides. If you can remember that fact or write it down, because remember, you can either have a page of notes or note cards. If you have it written down, remember it, you'll have no trouble at all solving this equation. Or sorry, this question. Question 7, we're looking at a bookcase. And we're going to be trying to build a bookcase out of lumber. So when we look at this question 7, what we have is we've got a bookcase, okay, and we're going to figure out how to solve this bookcase question. So a bookcase is constructed as shown in this figure. The height of the bookcase is 4 feet, longer than the length of the shelf. 20 feet of lumber is available to use for the entire unit. We're not going to put a back on it, only the shelves. Find the length and the height of the unit. So first thing I'm going to do is I'm going to go ahead and draw this up. And let's make sure we've got all the pieces here. Okay, there should be 4 boards here, it looks like. Right? When we look at our picture, we've got a top, we've got a middle, another middle, and the bottom there. And what do we know? Well, we know we have a total of 20. So the most we have is we have 20 feet of lumber. Okay, so we have a 20-foot board, and we want to make this bookshelf out of that 20-foot board. Well, what do we know? It says, if we read it, it says the height is 4 feet longer than the length of the shelf. So the height is 4 feet more, and the length of the shelf is unknown. So that's going to be x for the length, and the height is going to be x plus 4. Is everyone okay with that so far? Now, we know it has to sum up to be what? 20. So if we sum these all up, it has to equal 20. So if I sum them all up, I have 2 times x plus 4, right? And then we've got 1, 2, 3, 4 of those, so that's 4x. And that's going to equal now 20, because that's all the shelves put together, all 4 of the shelves, plus the 2 side pieces. That's going to give you 20, right? And you can finish it from here. Is everyone okay with how I set that up? So I just drew a picture. Now the one in your exam, I will tell you, is going to be different. The one in your take-home exam is different. They're a little bit different on the applications. Same type of questions, though they're a little bit different. When I give you the practice one, or the take-home one, and the one next week, when you take it on Monday, might have a different question here, but a very similar type of question. Question 8. So bank loaned out $55,000. Part of it at 2.25 per year, and the rest at 3.5 per year. The interest was $1,537.50. How much was loaned out at the 2.25%? Now, this question is almost identical to question 5. Not much different at all. It's going to be set up pretty much the exact same way. So when I read this, it says the bank loaned out $55,000. So that goes over here for the total amount. So there's your $55,000. We have an amount, and we have a percentage rate. So the first rate is that 2.25%, and the second rate is 3.5%. And just like question number 5, we don't know either one. So do we know how much is at the 2.25%? No, that's unknown. But we also don't know how much goes here either, but we know that that is the total amount minus X. So that's going to be 8,000 minus X. That's going to, or sorry, not 8,000. Why did I say that? Sorry, I was thinking of the other one. It'd be 55,000, right? So that's going to be 55,000 minus X there. Now we can use that to build our equation. And then once you have that equation built, then you can solve it. So let's go ahead and build our equation. We're going to talk about the interest here. And interest is the amount times the percentage rate on the first one. What do we have? We have X for the amount, and rate is 2.25, so that's 0.0225. We've got the X attached with it. Then we're going to add on to that 0.035. And how much is in there? 55,000 minus X. And it does not equal 55,000. It equals $1,537.50. There's your equation, and you can finish it from here. The very, very important part is how to set them up. You shouldn't struggle with solving. Solving is the easy part. No one really struggles with that. It's all in the setup. Question 9. Very, very similar again. A lot of these are very repetitious. Kevin invested part of his $9,000 bonus in a CD that paid 2%. The other paid 4% in his mutual fund. And he made $130. How much did Kevin invest in the mutual fund? So, what are we going to do? We're going to look at this as an investment question. And we've got Kevin here, and Kevin has a total amount of money to invest of $5,000. So there's Kevin's total. And each of these has an amount and a percentage rate to go along with it. And it looks like he invested part of it in a CD, and that CD paid 2%, and the rest in these mutual funds that paid 4%. And just like the other two questions before it, 5 and 8, we don't know how much is in the CD, so we use an X to represent that. We also don't know how much is in the mutual fund, but we do know that that is going to be the total minus X, and so that is 5,000 minus X. Now we build our equation with the interest, and that is the amount times the rate. And what do we have so far? We have a rate of 2%, so 2% would be 0.02. Amount is X. Add to that 0.04 for the interest rate, and the amount is 5,000 minus X. And then what does it equal? It says we made $130, and that's total interest. So pretty easy on the setup there, and I think you can finish it from here. But I really want to make sure we know how to set these up. Now, there are different ones on your take-home exam, and there's one I do want to set up for you on that one as well. Question 10, believe it or not, is actually one of the questions that students are most likely to miss. Students are likely to miss this one because of the fact that when you work with interest, it has to be in terms of years. And this one has months in it. So we have to make sure when we work with this particular question that we actually make sure we use years instead of months. Now our interest formula is I equals PRT. And let's just read this question here. So Levi borrowed $4,532 at 6% simple interest for 6 months. How much will the interest amount to? And what's the total amount that Levi has to pay back? Okay, so principal is the P. Now that's how much money we start with. And Levi took out this loan, and this loan started for $4,532. And R is the rate as a decimal. And it's 6%, so as a decimal, it's 0.06. Here's where students make a mistake, T. T is the time in years. Now, we are not borrowing this money for 6 years. We are borrowing it for 6 months. So since it's in terms of months and we want it in years, we take that 6, we divide it by 12, and that gives you the half. Half of a year. 6 months is half of a year, not 6 years. Right? If you use the 6, that would mean you went it for 6 years. You didn't. You only took it out for half a year, 6 months. So now we can find our interest. And that's 45.32. And we're going to multiply that by 0.06. And then a half as a decimal is 0.5. Multiply all that together. Easy enough. And that gives you $543.84. And we want to know how much we borrowed, or how much we had to pay back in interest, and also how much money we actually owe. Let's see, did I make a mistake here? I bet I did. Something doesn't look right. Let's make sure we wrote it down right. I think I made a mistake. Let me look and make sure. So we've got 6%, that's there. 6 months, that's there. Let me double check and make sure I didn't lose a decimal. Yep, I did. I think I put multiply by 5 instead of multiply by half, and that should be $135, sorry about that, and 96 cents. I just multiplied it by 5 instead of 0.5. And so the interest is simply going to be $135.96, easy enough. And the total is that $45.32 plus $135.96, and that gives you a grand total that the bank gets in return 45.32 plus 135.96. The bank then gets back $4,667.96. Where is the mistake going to be? If students make a mistake, it's going to be in that 6 months. Someone will use 6 years instead of 6 months. So make sure you're very, very careful with that. We'll go through a couple more, and then we'll take a short break. I want to get through most of these applications before I take a break. So we'll try to do 2 more. Question 11. Meg drove to her appointment at 50. 40 in the afternoon when she came back. Return trip took a tenth of an hour longer. How far did she travel to the appointment? Remember, when we talk about distance problems, they can either add, they can subtract from each other, or they can equal. Well, in this case, if I'm going to the appointment and I'm coming back, they're going to equal. Now, what do we know about these distances? We have a rate, a time, and we calculate the distance. So my rate, when we go in the morning, is 50. Rate in the afternoon well, that rate is only 40. And then we've got our time in the morning and our time in the afternoon. Now, what we don't know is our time in the morning, because it says the return trip, it took a tenth of an hour longer. So the morning time, we don't know, so we use an X there. In the afternoon, it says it takes a tenth of an hour longer, so that's going to be X plus 1/10. Let's go ahead and set these equal and see what we've got for our equation. Because the distance equals the rate times the time, and we've got morning, and we have the afternoon. And we know these are going to equal each other. So in the morning, it's easy. Rate times time, well, that's simply going to be 50x. And in the afternoon, 40 is our rate of speed, and the time is x plus 1/10. So you can finish it from here. Now, one thing I'm going to have to tell you is you're going to finish it, and you're going to solve it for x. But we want the distance. Right? It says we want the distance. So what we do is we take it and we plug it back in. So you're going to solve it for x. We want the distance, and so we'll just do it for the morning. Your distance is 50x. So you're going to have to then solve it for x, and whatever you find, you plug it back into here. So if your time was 2 hours, right, plug that back in, you actually traveled, or she actually traveled 100 miles. So whatever you find, you plug it back in to your distance formula, and that's going to give you how far you traveled. We want the distance, not the time. You solve, you get the time, but we want the other one. We did one just like 12 earlier. Now, I did cut your exam down to, well, your take-home one's going to be 20. On your in-class one, I'll probably make it either 21 or 22, and you're going to be able to skip 2 or 1. So if I make it 21, you'll be able to skip 1. If I make it 22, you'll be able to skip 2 of them. So you won't have to do 25. You'll only have to do 20, and there'll probably be at least 1 or 2 of them that you can skip. When I made up your take-home exam, it has 20 questions. So your real one's going to be in between the two. But you're only going to have to do 20 total. Question 12 is a mixture one. So how many liters of a 20% are going to be mixed with 80 liters of an 80% to get a 30? The only hard part about the mixture questions is making sure that the percentages go in the right place. And this is what we want at the end. Okay, box number 3 is what we want. Now let's see what we've got in the beginning. So when we read question 12, it says, how many liters of a 20% solution? So obviously we don't know. We know it's 20. And we don't know the amount, so we use an X there. And we're going to mix this with 80 liters of an 80% solution. And watch for keywords. It says to get. So that means what I want, right? I want to get a 30% solution. So that means that 30% is going to go over here. And adding across, well, that's X plus 80. Simple enough. So now let's go ahead and build our equation here. And we're going to be looking at the pure. And the pure is the amount times the percentage rate as a decimal. And so that first one is 0.2 times X, right? Those get multiplied together. The second one is easy as well. It's 80 times 0.8 for that 80%. And then what does it equal? It equals 0.3 times X plus 80. And I think you can finish it from here. Now let's see if we can't finish out at least one more, maybe both of these applications. The next one's pretty easy to set up. Question 13 should be pretty easy to set up. From a point in the river, 2 boats are driven in opposite directions. One at 7, one at 9 miles per hour. And in how many hours will they be 64 miles apart? So when we work with the distance ones, remember we have options. They can add, they can subtract, or they can equal each other. Now it says here, these boats are traveling in opposite directions. So that means when I start here, one is going to the left, and one is going to go to the right. Is this addition or subtraction? And why? Are we going to be adding or subtracting these?
Subtracting.
Nope.
Or adding.
We're going to be adding. Now, why are we adding and not subtracting? When do we subtract? We subtract when they overlap.
Oh, okay.
When they're directly on top of each other. They either subtract or equal. Like question 11 up here. Okay, this was an equals because they overlapped, right? And they should be the same. If you have 2 runners in a race going the same direction, then they're going to add. Or sorry, subtract from each other, right? If they're going the same direction, running a race, One's faster than the other, and you want to figure out by how much, so you subtract. Now, when I look at this one, these are not overlapping. So that means that these are going to add together. So they do not overlap. They go in opposite directions, so they're going to add together. And this one's easy because one of them has a rate of 7. One of them has a rate of 9. And the times, well, we don't know, but we know they're the same. So we can use an X here. And our total distance from this question is 64. So now we can simply build our equation. And we'll just call this one 1 and this one 2. And we'll go ahead and take a break after this question. Come back and then work some more of these. So this is what we've got. We're going to add them together. And our distance is the rate times the time. And the first one is 7x. The second one is 9x, because they multiply together. And then over here is the total distance. And that total distance is going to be that 64. And I think you can finish it from here. Okay, we'll take a short break, and then we'll come back.